Hello, Physics Nation. My name is Nate Lamond, and I was halfway through the spreadsheet video. So this was interesting. Um, we dropped the ball 5 times from 3 meters, 2.5 meters, 2 meters, 1.5, like that. And the acceleration is supposed to be 10 meters per second, no matter what distance you drop it from. So what went wrong? Why did we get such a high, percentage error? It's just like 18 meters per second. That's 80% away from target. And it got down to zero, like we got better and better and better. So why? That's sort of going to be the focus of the conclusion. I can't write, while I'm recording, but let's do some easy formatting cleanups for the graph and for the table and paste it into a doc and sort of assemble our lab report. So this graph is looking good, but I like it when the axis starts at 0. So hit the 3 dots, edit chart. It's under customize. And hang on, let me zoom out here. Whoa. I think that's under horizontal axis. And then I want the minimum to be 0. There you go. I think that looks better. And we can make the maximum 4 just to give ourselves a little bit of space here. Okay. So graph looks pretty good. We can actually get out of that. We're going to right click, copy the chart. Let's throw that in. Let's throw that into our Google Doc. We can switch up the order later on if you like, but I'm just going to start with the graph. I like it when it's linked. I think that's cool that the edits show up here. You just press the little update button. I think that's cool. Okay, so graph is looking good. Like I said, we were horribly inaccurate, and then we got better, and actually, hit the target, 9.8 meters per second. Crushed it at 3 meters. Let's clean up this stuff a little bit here. Let's actually center all of this. I think it looks better when it's all centered. And let's put a grid around it. Let's fix these significant figures. And I actually want to draw a second graph. I want to see how fall distance affects percentage error. Hold control for that second column there. Insert chart. Not a column chart. We're going to do scatter plot. And that's interesting, right? Exactly the same shape. High percentage error going to low percentage error because 10 is the target. All right, let's get these labels in here. This is percentage error. And this is drop distance in meters. And what should we call this? Accuracy, accuracy in free fall acceleration as a function of drop distance. All right, so a little long and awkward, but that's okay. So we were really far away from the truth when we were dropping at a short distance. And we got closer and closer to the truth. In fact, we nailed the truth. This is super accurate. All right, so I'm going to steal this graph too. Oh, should we start this scale from 0 also? I guess. Let's have the scales match. When we go to 4, there you go. All right, let's get this graph in here too. Let's copy it into our doc. Uh-oh, 30 seconds to go. All right, this table is really, really wide, so let's try to shrink some of these times right here. We got a, oops, that might be a little too small. We got to try to squish this into the dock. Oh Man, not in 3 seconds. Shoot.